Hey guys, welcome back. This is our third video on related rates. This is the ladder problem, one of the most common related rate problems that teachers begin with. So let's do it. A 10-foot ladder is leaning against a wall, okay? And so let's take a look at what that looks like. So that's that. This is 10 foot. It's leaning against the wall. If the top of the ladder slides down the wall, so if it slides down, your next, I should make that actually a little bit, right? Next one, and so on. It's sliding down, so that's what that looks like. So if the top of the ladder slides down the wall at a rate of 2 feet per second, so it's coming down, I'm gonna put a negative there to indicate that it's going down. So 2 feet per second. How fast is the bottom moving along the ground? How fast is the bottom moving along the ground, okay, when the bottom of the ladder is 5 feet? Okay, so how fast is the bottom moving along the ground when the bottom of the ladder is 5 feet from the wall? Okay, so let's take a look at this. Currently, my ladder is 10 feet long. You guys can all agree that the ladder is not going to shrink or grow. The ladder has a constant and it's 10 feet long, but we all know that the distance from the wall to the ladder will change, right? It's gonna grow because the ladder is gonna be sliding down, so the distance will keep going out. And we also know that the distance of the wall is going to change also. It's going to get smaller because the ladder is coming down, right? So this is our information. Now, the wall is forming a 90-degree angle, so I'm going to use a squared plus b squared equals c squared, which is right here. And what I did was I solved for my third side of the triangle, okay? So the work is right there, and now I get this here to be 5 root 3, okay? You guys can pause the video if you would like. Now, that's 5 root 3. The rest is a piece of cake. A squared plus b squared equals c squared is our formula. I'm going to take the derivative with respect to time. So 2a dA dt, because it's a letter other than t, plus 2b dB dt equals 2c dC dt. Because each one of these has a 2 and it's an equation, I can get rid of it, okay, just to simplify. Now, A, remember what the picture looks like. I'll draw it really quickly and actually small because I don't want to take up too much room. This here was 5 root 3. This was 5. This was 10. And if you guys notice the ratio of the sides, you know it's a 30, 60, 90 triangle, okay? So this guy A, I'm going to make 5 root 3. I'll leave this blank for dA per dt. Plus B, I'll make 5, okay, dB dt. And C, I'm going to make 10, and then dC dt. Well, let's talk about this. I told you that the ladder was sliding down, and it was negative 2 feet per second. So I'm going to put the negative 2 right there, okay? Now, I need to work with units, but I'm just going to leave it alone for a second, okay? Get it for a second? Okay, dB dt is what the question's asking. How fast is this bottom moving this way? So I'm just going to leave dB dt. Now, we know that the ladder is not growing or shrinking. So the rate of change of the actual ladder is 0. Once again, the floor will be changing. It'll be getting longer as you slide this ladder down, and the wall will be shrinking as you slide the ladder down. So those two get numbers, but the ladder itself doesn't. So I'm going to put a 0 there. All right, so let's finish this. 5 times negative 2 is negative 10. Rad 3 plus 5 dB dt equals 0, 10 times 0. I'm going to add 10 radical 3 to both sides. And then I'm going to divide by 5. And then I'm going to get my rate to be 2 radical 3 when I reduce this. Okay, pause the video, rewind it. It's just some quick algebra. It's going to be plus 10 rad 3, then divide by 5. So it's going to be 2 rad 3. Now, this is the answer to dB per dt. What units are we using? Feet per second. So you need to indicate that here. The only reason why I didn't put it is because I don't have enough room on this iPad. So it's 2 rad 3 feet per second. So I hope that was useful and helpful, and I hope you see how related rates works in calculus. Whatever changes is the per part. The ladder did not change, so that's 0. In the next example, I'll be doing an airplane problem where all 3 will be changing. So come back and hopefully that will clear up why this is 0 and why in the next problem it's not 0.